Good afternoon, everyone. Whenever I talk to anybody about how they got into mineral collecting, inevitably somewhere in the conversation it comes up that, well, I got started when I was, really young. It's usually 2 digits, but Brent started when he was 5, or so he says. Brent is a retired clinical pharmacist, and he took geology classes at the University of Utah, but decided it would probably be smart to do something that would make money. And then it would support his hobby. So he has been a very avid collector for many, many years. And this is an indication of how large his collection is. He has 3,000 mineral photographs on Mindat. So, and he has been involved very actively collecting, specializing in rare earth elements as part of his collection. But he's been involved in researching 14 minerals that are new to science. Very active collector, and after what we just put you through, we're going to be just looking at minerals for the rest of the day. So enjoy Brent's presentation on rare earth minerals.
You've seen this periodic table many, many times today. One thing that I want to specify on this periodic table is everybody else has kind of left out scandium, but I have collected some scandium minerals, or have in my collection some scandium minerals. So I took some pictures of them and have them included in the talk. As you can see, scandium is about yttrium. I am not going to talk about yttrium minerals today. And the reason for that is 140 yttrium minerals. And I have slides of probably 30 yttrium minerals in my collection. So if I included them in this talk, we would be here for 2 hours. So no yttrium minerals. I did include one photograph only because the person that it's named after is a good friend. And so I've got it at the end. We've already talked about this, so we don't really need to go into it any further. Rare earth elements are not really rare. As a matter of fact, they're 200 times greater than the crustal amount of or abundance of gold. So gold is rarer than most of the rare earth elements. The problem is they're hard to separate. And we've already talked about that. This is the production of the rare earth elements. As you can see, China is way off the chart. And I'll talk a little bit about the locality in China. It's an interesting locality. You've seen this chart before, the production, so nothing new there. We've talked about the uses of the rare earth elements. That hasn't changed. They're important. The US would like to get away from them because they have to import most of their rare earth element minerals from China. And China has the ability to decide who gets rare earth elements. If we're not on good terms with China, we don't get as many. So the US, instead of trying to find rare earth element deposits, as was talked about, they're trying to get away from using the rare earth elements. When I go to the NCMA meeting in California, we always drive past the spot in California where the mountain pass, and every time we drive by, it looks inactive. So I don't know if they're mining it. He says they're mining it now, but it comes and goes. And so the US just, that's not their push. And I think a lot of it has to do with the environmentalists. That's my opinion. All right, so the first one we're talking about is lanthanum series minerals. 86 minerals contain lanthanum. This is one from New Mexico, and it's on fluorite. It also has bastnasite, Ce, at this locality. The agardites, of course, have 4 of the rare earth elements: agardite La, agardite Ce, agardite yttrium and agardite ND. So there are 4 rare earth agardites. Next one. This is anselite, La, from the Kibany Massif in Russia. This mineral occurs with natrolite. It's one of the largest natrolite deposits in the world. Most anselite La is not very well crystallized. These, even though these are small, this is a field of view of 1 millimeter. They are well crystallized anselite crystals. This is a ferrianolite from Indellen quarries. This is a pumice quarry in Germany. Quite a few rare earth element minerals occur there. In fact, I have written down that there's 20 rare earth element minerals that occur at the Indellen quarries. So it's quite a large quarry for rare earth elements. This one's pretty unique. I think this is the only photo on Mindat of Iraqite La. To tell you the truth, I don't know much about the locality other than nobody can collect there. So it's a unique specimen in my collection. It doesn't look like much, but it's the only locality and the only specimen. This is a beauty. This is Kozoite La, and this comes from Japan. There are 2 Kozoites from Japan. There's a Kozoite La and a Kozoite ND. They're both pink. Both of them are spherical in shape. The Kozoite ND is more spherical, but they're platy inside. So once they're broken, you can see that they're plates. It's not a well-known locality. These occur in pumice, and so it's a volcanic locality. This one isn't real pretty, but it's mangan cascalite, CaLa. Now, I don't know why they have put Ca and La in parentheses. I know that they used to do that, telling us that the Ca is more dominant if it's in front than the La. But just recently, they've added that in parentheses to several of the rare earth element minerals. So, and this is a small quarry in Italy. It's a manganese quarry. They've worked it since the 1600s. You know, they use it for marble and other road grade quarry material. This is an interesting one. Paratuite La. There are several rare earth element minerals that occur at this Australian locality. This is a copper rare earth element mineral. It occurs in sandstone. So this is a little bit unusual, a little bit different than all the other rare earth element minerals that we've talked about that occur usually in granites or batholiths. This one's different, but it occurs in sandstone. These haven't been on the market very long. It's only been about 20 years when they were discovered. The copper mine had been in production for many, many years before, and then some mineral collectors in Australia went out digging around and found 4 new rare earth element minerals from this locality. This is another one from Indellen quarries, Periorite La. As you can see, in parentheses, it has lanthanum, cerium, and calcium. Obviously, the lanthanum is more dominant than the cerium and the calcium, but they all have to be in the structure. This one's an interesting one. This is a Wakefield La, and it's a lanthanum vanadate, which is really unusual. The combination of lanthanum and vanadium in the structure, really tiny. This is 0.75 field of view. It's a tiny mineral, but it's really pretty. As you can see, they're actually little red plates. We're done with the lanthanum minerals, and we're going to go into the cerium minerals. Cerium minerals have over 189 minerals that contain cerium. So cerium is by far the largest rare earth element mineral to be found, and it's the most abundant for mining. The rare earth is the cerium minerals. This is a Gardite seed from the Clara mine. Most of you are familiar with the Clara mine. It's once again an aggregate mine that they use, and also they mine it for metals. Quite a few metals occur at the Clara mine, so there a lot of silver is mined from there. At the Clara mine, there are 33 rare earth element minerals. The operation is huge. Is probably one of the localities that has the most tight locality minerals in the world. This is one that has just been found recently, aluminocerite. Once again, you can see cerium is the most abundant, but calcium is important in the structure. So it's Ce, Ca, and this is from the Montoso quarries in Piedmont, Italy. Once again, an aggregate quarry that's been working for hundreds of years. These are found in the little vugs of the aggregate minerals. Arisite, Ce, this is from the Aris quarries in Namibia. Once again, this is a road gravel quarry and railroad. One of the quarries is called the railroad quarry, and the other one is the Aris quarry. This particular specimen, Arisite Ce, comes from the Aris quarry. Probably some of the best arisites in the world. The crystals are great. It hasn't been very long that these the minerals from these quarries have been collected and described, and they're still working on several new minerals from these quarries. They're huge quarries in Namibia. I've talked to several people that have collected there. They get permission from the quarry owner and just go in and collect as much as they want. I think it has 19 rare earth elements at the quarry. Another one that I just love, astrocyanite Ce. The yellow is Komodoite Y, and this comes from the Komodo East mine, and it's a uranium mine. Astrocyanite Ce is the only, that's the only known locality in the world. The color and structure of the crystals is just amazing. Once again, from Aris quarries, bastnasite Ce, a little bit different than all the bastnasites you usually see. You usually see nice hexagonal crystals. Well, they're there, but they're so tiny, they're forming the white sphere. So that's also from Aris quarry. One from Utah, imagine that. This is Brechite Ce. This is from a mine down by Moab. It's called the Cane Creek. Mine was an underground mine until the 1970s. So this specimen came out before 1970. After the 1970s, what they did is they pushed fluid down into the mine and then collected the evaporate that comes up. And so now it's an evaporite mine. And so there's no longer any specimens. And sylvite is the mineral that they are actually collecting. Here's a quarry that most of you are familiar with, the Mont Saint Hilaire. I call it Buceyite, but it's probably Buceyite Ce. And this one, if you'll notice in the formula, it has Ce and then it has Ree. So like the other talk, the last talk, he mentioned that rare earth elements occur together. And so there could be 6 or 7 rare earth elements in the structure of these crystals. And of course, Mont Saint Hilaire is one of the largest quarries and rare earth producing mines in the world. There are 56 rare earth elements that occur at this locality. That's the most of any place. So it's abundant. However, I don't know if they're certainly not mining it for the rare earth elements. It is a byproduct of the aggregate that they're mining. Okay, we come to the largest reserve and mines in the world. And of course, this is Bayan deposit in China. This particular specimen, Sebaite CE, is from the East Mine. There are 2 mines there. It is estimated that this deposit alone has 70% of the reserves of rare earth element minerals in the world. So this is a huge operation. This is in Mongolia, up in the mountains. And these are just huge mines. They, if you look at some pictures on Mindat or under Bayan Obo, the extent of the mine is just unbelievable. This is Sarvendonite CE. This is from Mont Sarvendon area. These minerals, there's 2 of them actually on there. There's Trinobite Y. That's the yellow one. The black one is this Sarvendonite CE. But these minerals are found on the talus slopes of the Mount Sarvendon. And so the talus that comes off the mountain is where they've collected these specimens. This is Disacosite CE, really an interesting mineral. It's from Trimons. It's a quarry or a mine in France, and it's actually a talc mine. These rare earth elements occur not in the talc, but in small dolomitic lenses in the talc. And so as they're mining this, if they have a little bit of dolomite, the disacosite will occur with it. Diversalite C, really interesting mineral. The color and the fan shape of it. This is from Yukspor Mountain, Kibiti Massif, Russia. And once again, these are huge, huge deposits. And there's quite a few rare earth elements in those deposits. This one in particular is a granite pegmatite, and there are 3 rare earth elements that just occur at this one deposit. Florensite CE, these occur on quartz, and they are, they came out, what, about 5 or 10 years ago? Somebody at one of our micro mineral meetings had several of them. And they're nice little hexagonal crystals on quartz. This particular locality only has 2 rare earth element minerals, so it's not a big producer. You don't hear much about Argentina as far as rare earth elements. Francois CE from Wallace, Switzerland. There's also Francois ND. So there's both neodymium and cerium. And these, as you can see, these are uranium minerals. And so it occurs with uranium. This prospect only has 3 rare earth element minerals. One of my favorites, gadolinium CE. Once again, in the formula, they've actually, instead of just put rare earth elements, they've listed the abundance of each rare earth element in the gadolinium structure. So CELANDY are, of course, the CE is the most abundant, but the other ones are important in the structure. This locality is really small locality, and it's actually first mined for manganese. And so they mined it for manganese and then found these rare earth elements. Italy, I don't know more how many of you collect rare earth element minerals and put them in your collection. But Italy is one of the foremost countries for rare earth element minerals that you can actually see, even though these are micros, you can actually see crystals in the structure. So Italy has been producing, especially in the last number of years, a great deal of rare earth element mineral specimens. This is another one from Bayan Orgo. It's the yellow mineral, kind of yellowish green. The purple is fluorite, and it's yttrium fluoride. Even though yttrium fluoride is not a recognized species, some of the fluorite from around the world, especially this locality, has abundance of yttrium in the structure. And usually they're very, very dark purple. So yttrium fluoride is the nice purple mineral with the yellow-green. Lanthanite, CE, it's just a really simple formula, cerium carbonate. This is from a locality in France, and it's the only rare earth element mineral from that locality. Laplandite, CE. This structure is interesting because look at the chemical formula. You got sodium, cerium, titanium, and then you have phosphorus, not phosphate, but you have phosphorus, which is an unusual way to put that in a chemical formula. And then you have the silicon and oxygen. Usually the phosphorus would be with oxygen, so you'd have phosphate. But they didn't. They decided that the structure is not associated with oxygen in the crystal structure. Once again, this is from the level 0 massif in Russia, very similar to the Mount Kibani massif in Russia. They're very close together. Again, extremely large deposits. And this is mainly mined for apatite. Monazite, CE. This is from a small quarry in Italy. It's the only rare earth element mineral at that locality. Really simple structure, cerium phosphate. One of the problems with monazite is separating the cerium from the phosphorus. And so that's why it's hard to mine, or not hard to mine, but hard to separate it and get the cerium unattached from the phosphate. This is a relatively new one, motanite or motanite, CE, extremely long formula. This is from Monte Cavalluccio. These are in the Alps on the Italian-Switzerland border. I imagine it's a little bit difficult to collect.
What is the sigma?
That means that there is a site open and they don't know what the middle is. Usually you'll see a square. And
I see that as well.
Yeah, it'll just say there's an open site in a crystal structure, but they have not identified what form or what element is possessing that site.
Sorry, I think the question was sigma 2 means that the cerium and rare earth together are 2 atomic atoms per formula. I think that was the question.
Oh, is that what it is? The sigma 2?
Yeah, it's the sum of what's in the parentheses.
Oh, yeah, so the rare earth elements that are along with the cerium are this sigma 2 rare earth elements. This is an interesting mineral, the nibosite from C. This also has niobium in it. I asked a question earlier. A lot of people are talking about niobium as a rare earth element. It's not a rare earth element, of course, but it does occur a lot of times with rare earth elements. And the interesting thing about this is found in a mine in Greenland. They were actually mining for steenstruppine CE and uranium. And so that's what they were looking for. And then along with the steenstruppine and the uranium, they found this new mineral, the nibosite CE. Not a real exciting mineral, but nice crystals. And that mine has once again been closed. So the material that they're looking at is all from the dump of the mine. Nagarathite CE, once again from the Dindellan quarries. Parasite CE, synchesite CE. We talked about that a little bit. The parasite and the synchesite actually grow together in the crystal. And so you can't really separate them out. This one's from Norway. Norway has a lot of rare earth element minerals. I don't have many photos of Norwegian rare earth element minerals because they're usually black. So a lot of the Norwegian minerals, the gadolinite, are black and not real photogenic. Peprosite CE, once again, cerium and lanthanum, and this is from Caprinica, Italy. Nice yellow plates, interesting mineral. It's actually, this quarry is still active, so they're still mining this. So there's a chance that there may be other rare earth element minerals from this quarry. This is also from Caprinia, Stillwellite CE. This is an interesting mineral. It has cerium and boron in the structure. Really nice light pink crystals. Once again, unusual to have, a rare earth element mineral that crystallizes so well. But these are, once again, micros. Here's a good synchesite CE. Nice hexagonal plates, pink hexagonal plates. This is from the Petersburg quarry, and this is the only rare earth element mineral at that quarry. But these are probably some of the best synchesite CE minerals in the world as far as specimen-wise. This one's not, it's hard to see. It's tancanite CE, but I want you to notice it's with molybdenum, which is an unusual occurrence. This is from the island of Sardinia in Italy. From what I understand, this molybdenum is just in small lenses. And so there will be, like a seam of molybdenum, and then it'll just all of a sudden just open up a little bit and have some quartz with molybdenite, and you'll get some secondary minerals. Another really interesting one, this is yttrotungstite, CE, cerium and tungsten, and this is from Uganda. And this is the only rare earth element mineral at this locality. However, there is an yttrotungstite Y, and that comes from a different locality. It does not occur at this locality, but both minerals occur at the other locality. Another uranium mineral, Francois. Now we're into neodymium minerals. There's 54 minerals that have neodymium in the structure. but there's very few specimens that have neodymium as the most abundant element in the structure. So a lot of the minerals have neodymium as the rare earth elements, but not as the dominant rare earth element. This is also from the Komodo East open pit. This is one of 5 rare earth element minerals found at the Komodo mine. This is a beautiful one. This is the Geisingite in the nice pink crystals, and it's on Chrysocolla. San Duchessa mine, not a big producer of anything, but except for these beautiful crystals. Lanthanite ND, this is from Brazil. These crystals get large. They can be up to maybe 10 centimeters. This is once again in the production. I think you notice that Brazil is up and coming for the rare earth element minerals. So this particular mine is going to be important in producing rare earth element minerals for Brazil. Another really pretty mineral, a monazite ND, Monte Giove, Italy. Simple structure, neodymium phosphate. Beautiful crystals. Here's another one that contains copper. This one also contains lead, neodymium, and it's a copper lead neodymium carbonate hydroxide. Schuengite ND from the Kasopi mine in Katanga. This mine actually is not a mine. It was just a prospect. It's about 30 miles southwest Shinkolobwe. And so never actually mined, but the prospect producing beautiful Schuengite ND. And it seems to me like there was also, let me go back. There's also Geisingite ND at the San Duchessa mine. Swamboite ND from Swambo Hill, Katanga. I don't have much to say about Swambo Hill. Once again, just a small area prospected for uranium. Now, Leverson and I were into the gadolinium minerals, and it's the gadolinium minerals that there's only, if I remember correctly, there's only 6 minerals with gadolinium as the primary rare earth element. Most of you are familiar with the Shinkolobwe mine. This is the mine that provided the uranium for the Manhattan Project. And so it's extremely famous, a huge mine, closed now, been closed since the 1980s, but still produces specimens. There's artisanal miners that go in and mine for specimens. And interesting fact about Shinkolobwe is 57 type locality from that one locality. Interesting mine. Keviite, now we're into the terbium. So once again, there are only 5 rare earth element minerals with the terbium as the main rare earth element in the structure. This is from Mount Ploskaya in Russia. The purple is again yttrium fluoride. You see that deep purple with these rare earth element minerals. That's a really abundant yttrium fluoride. Xenotime, YB. This is just a terbium phosphate. This is one of the other ones from Norway. Not really exciting, but pretty rare in crystals. Some of these rare earth elements are really hard. If you're a rare earth element mineral collector, it's going to be very difficult to get for example, the ytterbium minerals. So you have to look around and be aware. And then to get one that's actually crystallized is almost impossible. Okay, we'll go to scandium. Like I said, I've included in the rare earth element minerals because it's in the same column, has some similar properties to the rare earth elements. Most purists don't put it with rare earth elements, but I think it forms really interesting minerals. This is a beryllium, scandium, iron, magnesium mineral from Switzerland, basite, a nice barrel-shaped, a beautiful blue mineral. This is a mineral from Russia, duonite. It's a calcium, magnesium, scandium phosphate. This mineral and this mineral are very close in structure as far as how the crystals form. This one is just scandium phosphate, whereas this one has calcium and magnesium in it. So different colors. The cobalt from this locality in Austria. This locality probably has the best cobalt in the world. Most people to collect scandium minerals will have a cobalt from this locality, and they get pretty large. You can get a cobalt that's maybe 2 to 3 inches, or a grouping of the cobalt up to 5 inches on a specimen. This is one of my favorites, thorviatite. It's a scandium silicate from the Sula mine. Thorviatite comes in several different colors. Most of the time it's white and it's acicular. But at this locality, for some reason, they are blue. I don't know why, but they're nice little puffballs of acicular crystals. And of course, the last mineral, like I said, there's 140 yttrium minerals, so I didn't include it in the talk, but this is named after one of my collecting buddies, Al Wilkins. This one is actually from the Val d'Oro mine in Trento province, Italy. But it was first found at the Blue Lizard mine in Utah. Al actually found this specimen underground at the Blue Lizard mine. And so they named it after Al. Beautiful acicular yellow needles, really nice crystal form and color and specimen. And it occurs on sandstone at this locality. And this locality is very similar to the mines in Utah. So the Blue Lizard mine and the Green Lizard mine and the Markey mine, all those mines in the Red Canyon district have the same mineralogy as this mine in Italy. So that's my talk.
Questions?
Yeah.
I'm wondering, for example, the scandium silicate, why isn't the mineral called scandium silicate? Why is, like, most of the minerals didn't include the rare earth in it, even when it had a lot of cerium in it. It wasn't called cerium something or another.
Yeah. I think that one is thorviatite. Why didn't they call it scandium silicate?
Yeah.
Because most of these minerals are either named after the individual that found the mineral, or named after the locality where it's found, or named after an important mineralogist that does not have a mineral named after it. And so that's why it's called thorviatite. And this one, I think, is named after an individual. I'm not sure what his full name is, Thorvius, but it's named after an individual, not a locality or something else. Some of the minerals, one of the other talks told us that sometimes the mineral will be named after the elements in the mineral. That's a good question. There are several minerals that are just named after the minerals. In this case, it's named after the individual who found it.
So these mineral specimens, are any of those sites places where they would mine for these rare earth? Or would the rare earth element mining occur in different areas?
The Bayan-Obo mine is a rare earth element mine. That's what they're mining it for. That's the one in China. That's the one that has 70% of the rare earth element reserves in the world. Most of the other localities are not being mined for rare earth elements. It just happens, like a lot of the aggregate quarries and the granite quarries and some of these other mines. For example, the Paratua mine was a copper mine, so it was mined for copper. Other people know better than I as far as why or what places are being mined just for rare earth elements. Mountain Pass in California is being mined just for rare earth elements. But I don't know, do you know if there's any other mines in the world, or just some of the sand mines in Burma, was it? Are just being mined for rare earth elements? Most of them though, no. Just happen to occur with the rocks that they're mining. Any other questions? Yeah.
Yeah, you want to go? No, go ahead. I had basically two, I don't know, questions or observations. One, I noticed you would have the Wakefield, I think, was it Y? And
No, CE, I think. Wakefield, CE.
okay.
Yeah,
Have you seen the Wakefield CE from Yellow Lake up in BC?
I have not.
Super good.
Yeah,
And some of our members that, I guess, late members collected up there.
and that's the type locality is in
Yeah,
British
really nice.
Columbia. Yeah, that's
Pieces.
correct.
Also the biggest crystals in the world.
Yeah,
Yeah, they're super good. There's pictures on that.
they're a lot larger.
Then the other one was the 10Ka CE. I wasn't aware of that one. Molybdenum containing
Yes,
rare earth mineral there. That's interesting. You know, Washington Pass, that area up there that has a lot of rare earth minerals. And one mineral that is up there is molybdenite.
yeah.
And I've seen some that's been a little altered. And it just got me thinking, I wonder if potentially we could have something like that. I don't, you know. Just,
Yeah, and this tancanite C was just approved about 6 or 7 years ago. So it's relatively new. But I thought it was interesting because
wow.
that's the first rare earth element molybdate. Yeah, molybdite that I've seen. And you had a question. Yeah.
I just wonder, many of the minerals that you've shown here are small,
Yes.
millimeter or less fractures in some other thing like an aggregate. How do they get discovered? How does somebody notice that there is this little bit that's different and discover that it's a mineral species?
We're asking the right person.
Well, first of all, you buy yourself one of the best microscopes that you can find in the world. and you look at everything that you find with a loupe. So you pick up a rock, I have my loupe in my pocket here, and you look at it with your loupe. If you can see something with your 10 power loupe that you don't recognize, then I take it home and look at it under a microscope, sometimes up to 150 power. So I will go all the way up to 150 power. 150 power is approximately field of view of 600 microns. So you are getting down there. Some of my pictures, like this one, this is 750 microns. Not a very good picture, but you can see the form and you can see the color. But those crystals are probably only 300 microns.
Bruce,
So the erosite you showed,
Yeah,
it looked like, I couldn't quite interpret what I was seeing. It looked like it could be zoned, or it looked like it might be kind of beveled on the edges.
No, it's actually multiple crystals.
Oh, okay. Like that.
Yeah.
Considered that.
That's what's causing it. Yes, Ray.
Just a quick question, because if you're getting this kind of photographic excellence at 150 times, are you getting, what kind of lighting are you using, or are you stacked?
None of these photos are stacked.
Good, good, I'm glad to hear that.
I just take the photograph through my microscope, a third lens. I have gooseneck lighting, and I light the area that I want to see. The ring lights are great if you want to light up the entire specimen, but if you just want to light up, one little piece, then the goosenecks really work out good. Any other questions? Yes.
I do have a question, Brent, but I'm not sure this is actually your question, but maybe somebody else could answer it for me that's in the room. So we've heard today that rare earth minerals are not rare.
Right.
And yet, and yes, there are macro specimens of rare earth minerals. Mostly know them, they're fairly common. But in the overall, there's sort of a problem here. Like, okay, so on the one hand, we've got something that's not particularly rare. Then on the other hand, it seems to be largely in all these micro minerals. So there's a problem with that.
In this case, specimens of rare earth element minerals, and the ones that I have pictures of, are tiny. But at a location, they could be abundant. So you could have, for example, this is a 750 micron field of view. So that crystal, and it's a twin crystal, is probably 400 to 500 microns. But you can see there's another one here. There's some more down here. So there could be an abundance.
Yeah, I think that's a good answer. And,
Yeah.
and yet there's still something missing in the answer, as in why aren't we seeing larger crystals of a lot of these minerals?
I don't know. Maybe you can answer that.
I'll show you.